Okay, so let's look at 10, 11, and 12, even though they're numbered 1, 2, 3. What's the difference between yield to maturity and yield to call? Yield to maturity is the yield all the way to maturity, but some bonds are callable, so they can be called in early. So you're going to have to change the end because there's less time to maturity and potentially the future value. So let me give you kind of an example here. Let's say we have a 10-year bond. 10-year bond semi-annual pay ends equal to 20. Future value is 1,000. It makes some kind of payment. Let's say it's an 8% bond, $40. The price of the bond, let's just say, see if I can write PV correctly. Present value is minus 990. I put all this in and I solve for IY. Right? I take that and multiply it by 2 because it's semi-annual pay, and it gives me the yield to maturity. If the bond is callable, all right, so maybe it's callable at 101% of par. So I change that to $1,010. Whatever maybe it's 1,000. It just depends. So whatever the new call rate is, and say it's callable in 7 years. So 7 years, I change that to 14. So that's the difference. Now let's look at this next one here. I've already worked this out for you, the duration of a 3-year bond. Let me tell you where all this comes from. It's got cash flows of 80, 80, and 1,080 over the next 3 years. And note, it's annual pay. So I need to find the present value. Present value would be 80 divided by 1.081. That's my 74. Then 80 divided by 1.081 squared. That's my 68. And then 1,080 divided by 1.081 cubed, that's the 854. Sum it up, that's the price of the bond. Well, what about my weights? So for the weights, I know that think of this as 3 separate bonds. That's the way I think of it. The first bond pays me $74, and I'll go on out with the decimals here. And the total I pay for the bond is $997.4275. So when I buy this bond, 7.42% of it is for the first bond, right? The payment that comes in year 2, that's worth $68.46 to me. The whole thing is worth $997.4275. So that's 6.86% worth of the bond. And the same here, the 854 over the 997, that's going to be 85% of the bond. So this will always add up to 1. And think of duration as the weighted average life of the bond when there's no call options or anything. So those are the weights multiplied by time. 1 times this, 2 times that, 3 times that, sum them up, and that's your duration. Alright, so this is interesting because of the next question. I want to immunize myself against interest rate risk. The duration of my liabilities needs to equal the duration of my assets. So my liability is a GIC. A GIC has a 6-year duration. It's a 0 coupon, right? And just real quickly here, if this were 0 coupon, if that were 0 and that were 0, then this weight would be 0. This weight would be 0, right? And this would be 1. So the entire thing, the whole value of the whole bond comes in the last year, and that would be 3. So the short version of proving if it's a 0 coupon bond, the duration is equal to its maturity. So the GIC has a 6-year duration. The amount I put in bond A, 4-year duration times the weight I put in bond A, plus 10-year duration times the weight I put in bond B. So the duration of a portfolio is the weighted average of the duration of the assets inside the portfolio. Well, 2 equations, one unknown, can't solve it, but I know the amount I put in A is equal to, the amount I put in A plus the amount I put in B is equal to 1. So weight of A plus weight of B is equal to 1 because I put my entire, invest everything in it. So 10 times 1 minus WA, making that substitution. WA is equal to, I got to solve it. I forget if it was 1/3 or 2/3. So this is going to be 6 equals 4 WA plus 10 minus 10 WA. So minus 4 is equal to minus 6 WA. So WA is 2/3, WB is 1/3. So when I sell this GIC, whatever I sell it for, I take 2/3 of the proceeds and buy bond A, and 1/3 of the proceeds and buy bond B. Okay, so now for the next few questions here, the ones in blue are what you had to fill in. So I'll need to find this return for the stock fund. So ending 170 divided by beginning 173.47 minus 1 is equal to minus 0.02. So that was the return. You would do the same thing to get all of these returns in there. And then the deviations, I got to find this average. That wasn't given to you, but I gave you that average. And I would take this return 0.029 minus the negative 0.0039. That would then add up to this deviation. Deviation squared, I just take this deviation right here and square it, and it gives me this answer. Of course, there are going to be some rounding issues, but that's fine. To get the variance of the bond, this number right here is the variance. I sum these up, and I divide, instead of 1, 2, 3, 4, 5, I divide by 4. So sum those up, divide by 4. And like we said in class, I don't care if you divide by n or n minus 1, whichever way. So there's pros and cons to both. So I just showed you the answer for n minus 1. And then to get the standard deviation, I take the square root, and there's the square root right there. To do the covariance, same thing, except I take this column, add it up, and divide by, I got to be consistent. If I did this by n minus 1, I have to do this one by n minus 1. So divide by 4 comes out to be 0. Okay, so 19, 20, and 21. Assume there's no risk-free asset. What's the least possible risk? How much should I put in the stock in the bond fund? So I need to have the minimum variance portfolio is what I'm looking for, which will be this formula: variance minus the variance of the bond fund minus the covariance of the stock and bond divided by the variance of the bond plus the variance of the stock minus 2 times the covariance of the stock and the bond. And remember, the covariance of the stock and the bond is equal to the correlation 0.3 times the two volatilities, which is 0.0075. Okay, so what I have here is this bond fund 0.10 squared minus the covariance 0.0075 divided by the variance of the bond fund plus the variance of the stock fund minus 2 times the covariance, and that equals like 4.35%. And how much in dollar terms? Well, there's some decimals there. If I multiply this answer by 10 million, I will have $434,782.61 in the stock fund, and then the remainder, 10 million minus that number. I won't write it down. 10 million minus that number is what goes in the bond fund. Okay, so this question, assume the risk-free asset does exist. What investment do you make in order to take the least possible risk? I put $10 million in the risk-free, right? So that's a gimme question. $10 million in the risk-free. Alright, so let's go to the next one here. I'm going to move this up just a little bit so we can see a little bit better. And let me bring something in so we can do this. Okay, so now I think we have the stuff we need. A client wants 8% return. You've determined the optimal risky portfolio, and I want to make sure you can do that. I mean, it's in the spreadsheet, so check and make sure you could come up with that if you were asked to do so. How much should be invested in the risk-free asset? Well, my client wants a return of 8%, and if I invest in the risk-free asset, I get a return of what was it? Hang on, let me see what it was. Okay, so the risk-free asset has a return of 1%, and then the optimal risky portfolio has a return of 10%. So in just let me get this looking better. That's WK. So what we're saying graphically, just a real crude graph here, this is 1% right there, and then here's the optimal risky portfolio. So you have the stock fund here and the bond fund there. The return right there is the 10.46%. So we've determined that, and I also know the weight in the risk-free plus the weight in the risky has to equal 1. That means when I solve for this, WF is equal to 26.02%. When I multiply that number by 10 million, it means 2,602,377.81 goes into the risk-free. That means the remainder, which would be 7,397,622.19, goes into the optimal risky. I didn't even ask you that question. Is how much goes in the risk-free. So in number 21, how much should be invested in the stock fund? Okay, so here's how to figure out how much should be invested in a stock fund. I know that my optimal risky portfolio is going to have, and I'm rounding from this number, 73.98%. So 73.98% of my money goes into optimal risky portfolio. My optimal risky portfolio is 58.75% stock. So the total weight in stock is equal to 0.7398 times 0.5875, right? And this is going to tell me the overall level, which is going to be like 0.4346. Multiply that by 10 million. I need to put 4,346,103.04 into the stock fund. So just one more time, if I want an 8% return, then I'm going to put some of the risk-free, which gives me 1%, and one of the optimal risky, which gives me 10.46%. Doing the math, I determined 26% goes into the risk-free asset and 73.98% into the optimal risky portfolio. But the optimal risky portfolio is not something you can buy on TD Ameritrade or Merrill Lynch. You're creating it by combining stocks and bonds like this. So this optimal portfolio, which you have $7 million in the portfolio, 58% of it is stock. So the total percentage of your portfolio in stock is 58% of 73%, which means 43%. Multiplying by 10 million, using all the decimals stored in your calculator, you put this amount, a little over $4 million in there. What's the volatility expected by the client? In number 21, I didn't write down the number. I'll look it up in just a second. But the volatility, or the variance, to start with the variance of the variance of any two-asset portfolio, is the weight in the first asset times its variance, the weight squared, plus the weight in the other asset squared times its variance, plus 2 times the weights times the covariance. This is easy because the risk-free asset has no risk. The variance is a measure of risk, so that goes to 0. The risk-free asset never moves. Covariance is the relationship of how they move together, so that goes to 0. I can take the square root of both sides, and the volatility of my portfolio is equal to the weight in the optimal risky portfolio times its volatility, which is equal to 0.7398 times 0.1640, which is equal to 0.1214. Alright, let me clear this off and we'll look at the last two problems. Okay, looking at the last two problems here, the client wants an expected volatility of 0.9. How much should go in the risk-free asset? Well, 0.09 should equal the volatility of the risky asset times the weight in the risky asset. So when I solve for this, WK is equal to 0.09 over 0.1640. That's equal to, I'm looking at the number right, 0.5486, which means the amount in the risk-free is 0.4514. So multiplied by 10 million, 4,514,000. What's the expected return? Well, the expected return on this portfolio, the client's portfolio, is 0.4514 times 0.01% plus 0.5486 times the 10.46%, which equals 6.19%. Alright, so that's the test. Let me know if you have any further questions.